What's up guys, Shawnthebro here, and in today's episode of the third person and action RPG tutorial series, we're going to be going over pings, waypoints, and markers part 2. For this episode, we're going to always have the pings face the player, or really the camera that the player is controlling. That way it is always visible to where they're at. So for example, if I place a waypoint here and I move around, my waypoint, my little ping there, is rotating to face the character. And this is called billboarding. There is technically a thing in Unreal called a billboarded material, and that would work for the individual icon. But if you want to add something like text or a line to the specific object that was pinged, like something in Apex Legends, then you'll want to be able to billboard the other objects as well. So this is just good to know how to billboard things. And so right now, our depth is still just in line with whatever we come in contact with. So you see it spawns in objects in the world, but you can clearly see as I rotate the camera around, it is rotating this object as well. And that's what it should be doing, so that is working as intended. Basically, wherever we are coming from, whatever direction, whatever point, we can see it in the world, and that's how we know it is working. Now, before we get into this episode, if you want to get caught up in the third-person tutorial series and the Action RPG tutorial series, I'll go ahead and link you to this playlist right here so you can check out every single episode, all the content from pings to equipment and an inventory system. Alternatively, if you don't care about that and you just care about the ping system, then I'll go ahead and link you to this episode right here, which is the previous episode of the pings, markers, and waypoints. That's part 1, where we initially created this actor and performed the ray trace or the line trace to spawn it where we are looking. Now with that out of the way, we can go ahead and get started on the episode. So this is a code and blueprint tutorial series. We're going to be doing almost everything in the code today, and then just updating our blueprint actor, our base ping BP, to have a little bit more flexibility and freedom. So if we go to the code, and specifically we want to go to our third person tutorial character.cpp, this is our base character.cpp. And the reason we want to come in here is because this is where we started creating the ping. We have this function called toggle ping that we created in the previous episode of the pings and waypoints. And if we go down to the toggle ping function, this was our behavior. We were getting the spot that the player was looking at, drawing a line, a debug line, so that we could visualize where that was at. And then if we had a blocking hit, we were actually spawning the ping at that location and the correct rotation. There's one small thing I want to add in here today, and that is to set the owner of the ping to be the class that spawned it. In that case, it is our third-person tutorial character. And the reason we want to set the owner is because we want to have some reference to relate back to, so that we know what to billboard this actor toward. So it should rotate toward the owner. Now in a multiplayer scenario, it's actually going to rotate toward everyone's camera. When they're looking at it, it should billboard for all of them. They see their own instance of it. That is absolutely something we can and will cover, so don't worry about that right now. But just be aware it is a little bit different. For the time being, since we only have one character, that is the character that we need to billboard it to. So we're going to go ahead and grab our created ping object. Mine is just called created ping, but whatever you called yours, grab that object. Arrow owner. Every actor in Unreal has this owner variable. It's just literally the owner of it, and it means that you can determine who should see it, who can use it, who it belongs to, all sorts of stuff like that. So this isn't a variable I made, it just exists, so you can just do arrow owner, and you're going to set it equal to this. This is not only the correct class type, but it's actually this specific instance of the object. And that's for the class that we are in, so that is for the third-person tutorial character. So literally, the character that had toggled the ping is this. And this is now the owner of the ping. So the character that created the ping is the owner of the ping. With that out of the way, we want to go to the base ping.cpp file. So this is my standard ping behavior. And in here, we want to update our tick function. We weren't doing anything in here before. All the default behavior was here where we are calling the parent functions with super. So we're going to add some new behavior for today's episode. So in the tick function, this is called every frame, we want to rotate the actor to face the owner's camera. That's essentially all we're trying to do here. The first thing we need to do is determine if the owning character is a third-person tutorial character, because this is the character that we're expecting on the base ping, so we want to make sure it is of that type. If the owner is of a different type, we may want to do different logic. To be able to do this, we need to include the third-person tutorial character file up at the top. So I go up at the top, below my base ping.h include, and I add a new include, hashtag include third-person tutorial character.h. Then back in the tick function, we make a new variable, auto, and I call it owning character. So it's automatically going to set this owning character variable equal to the correct type returned from this cast result. So we're going to say auto owning character equals cast a third-person tutorial character, and we're going to cast the get owner to that type. So if the owner of the base ping object can be cast to a third-person tutorial character, we can assume this is a character that will have things like the follow camera that we're going to need to billboard the object. So at this point, we can set the owning character to that result. Then I put all of this inside of an if statement, so that if owning character is invalid or null, it means the cast failed and we won't go into this behavior. If the owning character is valid, however, and it is an actual third-person tutorial character, we'll go into this if statement and do more logic here. Now, the next thing we need to do is determine the camera that we need to rotate toward. We want to make sure that the character has one. If for whatever reason we have multiple cameras or the camera has been deleted, we don't want to try and set the rotation using the camera, otherwise we will get a crash when we're trying to obtain the location from it. So we want to make sure the camera exists before performing this behavior. And we can do the same thing as above, where we're checking to see if this variable exists based on the result of this equal statement. So we're going to do auto camera to rotate toward. This is the variable I'm creating, and I'm setting equal to the owning character, which is the variable we got from the previous if statement, arrow get follow camera. The get follow camera function is a default function for characters in Unreal, but I will scroll down to it. Right here, get follow camera, it just returns the follow camera component, and this camera component is set up in the code right here. This is also from the third person template. It's not something we added, so unless you took it out, if you're using the third person template, you will have this. But we want to get that follow camera, because that follow camera is currently the one we are using when viewing from the game. So when we're controlling that character, that's the camera we're looking through. However, you actually can't get the follow camera without including another file, because the camera component is in its own file, and the get follow camera returns a uCamera component pointer. And so if the code does not know what that variable type is, it's going to throw an error. So we need to add an include. So pound include or hashtag include camera/camera component.h. And that will allow us to do this line right here. So we're going to set this auto camera to rotate toward equal to the follow camera of the character. And we're going to put all of that inside of an if statement to make sure it's valid. If it is valid, it means we were able to find the camera on the character. And that means we're good to go. We just need to set the rotation of the ping to the correct value so that the camera can always visualize it at the right angle. We can do this by calling set actor rotation, and then we're going to use something called the U-Kismet math library. This is a very helpful library, function library, that has a bunch of different functions we can use, such as finding the look at rotation. The look at rotation is exactly what it sounds like. It takes an object, it rotates it as if it is always looking at the other object that we give it, or the endpoint that we give it. And we want the ping to always be rotating and looking at the camera. That's exactly how we're going to get that billboarding effect. So we have our U-Kismet math library, : find look at rotation. Find look at rotation has two parameters, a start and a target. The start is where the object currently is, and the target is what we're trying to look at. And so the simplest way to do this is to just get the actor location as the start. Remember, we are in the base ping, so the ping's location is what we're starting with. and the target is the camera. But we need to put it in a location. So we take the camera and pass in the location of the camera. Now, to do this line, we're going to need one more include. So we're going to do our pound or hashtag include, and then Kismet/Kismet math library.h. And that will allow us to call this function right here. So now we just need to pass in our parameters. We have get actor location, and we want to use our camera to rotate toward the variable from the previous if statement, arrow get component location. And so this will make the ping always look at the camera. That's actually all we need to do in the code, but we aren't done quite yet. It likely won't work how we want it to until we go into the blueprint. So I'm going to launch the editor again. The editor is back open. We're going to want to go to the ping object. So my base ping BP here. If I open this up, I don't have any behavior in the event graph still, but if I go to the viewport, it is a little bit different now. In the previous episode, we had the base ping BP, which is the object itself, and then we had the sprite as the root component right under it. That was all we had, so we just had this little red arrow. Now I've added a plane, which I'll explain in a second, and I've also added a text render so I can display text to it. It's not required that you put text in here for anything. A lot of pings do include some little amount of text, such as like enemy or go or regroup, things like that. It's mainly for multiplayer, but if you are using it in a single player environment and you're putting a waypoint or a marker, it can put the name of the mission or the location that you're going to. So it can be useful in both scenarios. But putting another object under the sprite, such as the text, will allow us to test out our billboarding fully. So that is a good test, but you don't have to put it if you don't want to. The other thing I did was add a plane, and I added a plane because the default root component doesn't have a rotation, right? If you click on something like the sprite, you have your rotation values here. Your root component, which is always the top element here in your blueprint, doesn't have a rotation. This is typically fine, but when you are working with a sprite, a 2D asset, then you want to make sure that this object is rotated correctly, because otherwise you might get it looking like that, in which case you can't see it. So for me, my ping was actually like this rotation when I was spawning it in the world, and it was staying there, it was billboarding correctly, but it wasn't rotating how I wanted it. And so what I did was just add a plane to the base ping BP and took away the mesh. But this is the parent or the root component, and then the sprite is a child of it, so I could just change the rotation of the sprite. There are other ways to do this. I actually had it working in code with rotation, but I was then changing the billboarding values to add an offset manually, and I thought that was pretty ugly. So I decided to go with this instead because it's very, very minimal change and doesn't really add any complexity to the code or logic. So to do this, I added a plane component just by pressing plane here, but you can really use any component you have here. Preferably something that doesn't take up a lot of memory and doesn't have any logic, so one of the shapes. Then once you do that, you can see my settings for it here. The only thing that I did with it was remove the static mesh. When it comes in by default, it'll have some sort of static mesh on it. I think it is literally called plane. It's actually not this thing that I've selected, but you will have some sort of mesh here. And let's select the cube as an example. So it looks something like this. But if you hit the arrow, or if you click on the drop down and clear it, you'll have no mesh. So there's nothing here. But you still have the plane component. You'll see I haven't changed any other parameters here, but really you should probably change anything that doesn't need to be happening, like cast shadow can go off. We don't want to generate overlap events. And we don't need to tick on this function or on this component. So just take away things that are going to make this object more complex than it needs. It literally just needs to be there as a placeholder. So there you go. Now to make an object the root component, you can just click it and drag it up to here, and it'll say drop here to see available actions. Or if you do a different one, it might say this right here, drop here to make sprite the new root. The default root will be deleted. So if you make it the root, it will delete that component, or it will move it down. Regardless of how it ends up working out, you basically want the plane or the new object that you just used to be the root. That way the sprite is one step under that. Then once you have that change, you may need to rotate your ping. Now, the way to know if you have to rotate it is just come into the game and ping something. Yes, it has some collision with the wall, because we haven't figured that out yet. But if you look around, it should rotate with you. If you're not able to see the ping at any point, try it a few times. Make sure when you click on different objects that you can't see it. And if you can't see it, it's likely at a bad rotation, so that you're seeing like very small part of it, or you're actually seeing it just like that, where it's cut off because it's a sprite. So what I had to do was change my rotation to 90 degrees on the Z-axis. And when I did that, I was able to see it perfectly all the time. Nothing else in here has changed. You can see all my settings. And then I went ahead and added a text render to the sprite. So you can press add and text render. And here's the text render. I made it a child of the sprite itself, so when the sprite moves, the text render will also move. And I did move it to my own location, and I did rotate it by negative 90 degrees to get it facing the way I wanted. These are, of course, up to you with where you want to put the text. And then in here, under text category, the text variable, you can change it to whatever you want. So I wrote go. And you can change the materials and the font if you want. I did change the scale to be 3.0 instead of 1.0 to make it a little bit bigger. And that's everything I have for my text render. So at this point, I now have a working ping and waypoint that rotates toward the camera. Next thing we have to do with pings is to be able to clear them when we select them again, or when we are hovering over them with the camera. When we're looking at them, we can actually get rid of them, because right now I can just spawn a bunch in the world and they're all over the place, and I can't ever get rid of any of these pings. But anyway, guys, I hope you enjoyed this episode on pings and waypoints, and if you did, please subscribe. It does more for myself and the channel than anything else you can do, and I just really appreciate it. I want to give a huge shout out to my YouTube membership and Patreon supporters. Thank you guys so much for all the love and support over the years and for keeping this series alive. I'm so glad you're enjoying, and I can't wait to see what we do with this in the following year. If you had any issues with this tutorial or any of my tutorials, feel free to join the Discord community. I'd be happy to help you out, and that is completely free. Anyway, guys, like I said, that's all I got, so thank you so much for watching. I'm Shawnthebro, and I'll see you in the next one. Goodbye, guys.